Hello and welcome to today's class. Shall be discussing another way of solving quadratic equations, and that is by the use of quadratic formula. So basically, what we're going to do in this class is derive the quadratic formula that is usually used in solving quadratic equations. So basically, what you're going to focus on is the derivation of this formula that we use to solve quadratic equations. All right, so we know that the general format of all quadratic equations should be in the form ax squared, all right, plus bx plus c, all right, being equal to 0. Okay, so this is the general format of all quadratic equations. And so if you were to solve this equation by completing its square, then we would end up with what we call a quadratic formula. And so that is what the focus of this class is going to be. Remember, we said that for an equation to qualify to be a perfect square, the value of a should always be 1. So being that we don't know what the value of a in this case is, we are going to, before anything else, divide all the terms in the equation by 1. So that's the first thing that we're going to do. We're going to divide all the terms within the equation by a, all right, which is the coefficient of x, as you can see in that particular scenario. So when you divide x squared by a, you're going to get x squared. All right, and when you divide bx, all right, by a, you are going to get b all over a x. All right, and when you divide c by a, you are going to get c all over a, and all that will be equal to 0, because any number that you divide 0 by, is going to always give us 0. All right, 0 divided by any number will be equal to 0. All right, so we want to write this in a manner that then will let us write it as a complete square, as a perfect square. All right, so basically that means that we're going to have to take our c on the right hand side, the same thing that we are doing with completing square method. All right, so we're going to have it then as x squared plus b all over a x. All right, so c all over a to the right hand side is going to be minus c all over a. So that is what we are then going to do. Then after here, we will add the value of c that will then complete the square of whatever we have in the left hand side, as that is our main concern. So basically we know that that should be b all over 2, all right, should be b all over 2 squared. And I want you to note that the value of b here is b all over a. So what that means then is that we're going to add b all over 2a, all right? Basically, we're going to multiply b all over a by a half, all right? It's just the same thing as taking b over 2. So we're going to multiply it by a half. That is b all over 2. And when we multiply it by half, we get b all over 2a, all right? And remember, we are supposed to square it. And whatever you do on the left-hand side, you do to the right-hand side. So we are also going to do the same to the right-hand side. So we're going to have b all over 2a, and it is squared. All right. So far we're doing okay. We have in the left hand side a perfect square in a quadratic equation format. So we're basically going to factorize it. We're going to factorize the left hand side and then simplify whatever we have in the right hand side. Okay, so when we are factorizing the left hand side, note we are going to take x here and whatever we have in the bracket. Okay, so it's going to be x plus b all over 2a, all of that squared. All right, and that will be equal to, now we are going to try and simplify whatever we have in the right hand side of the equation, as you know, that is where most of the work of this derivation actually is in. All right, so notice b all over 2a squared will give us negative ca plus b squared all over 4a squared. So basically, we are going to square all the terms in that bracket, in that particular bracket. So it's going to be b squared and 2a squared. So that's going to give us 4a squared. And so I want us to then take our focus in simplifying the left hand side of the equation. All right, and then we're going to come and basically merge it with whatever we have on the left hand side. So remember that on the left hand side we've already written it as in its factorized version. So what we're trying to do is just simplify whatever we have in the left hand side and then find the square root of both ends. So on the left hand side, note that we can actually find the LCM of these two and write them in terms of an algebraic fraction. All right. So when you find the LCM of those two, note it's going to be 4. All right. And the highest value, the value of the variable of a with the highest power, the variable of a with the highest power. All right. So and that's going to be 4 and a squared. So that there is our LCM. Right, then we are going to try and write this one as one term in terms of an algebraic fraction. So we then ask ourselves 4a squared divided by a. Okay, 4a squared divided by a will give us 4a. All right, so a and a will simplify each other out to leave us with 4a. So 4a times negative c will give us negative 4ac. All right, it will give us negative 4ac. Then again, we are going to take 4a squared divided by 4a squared, and that is going to give us 1. Then 1 times b squared, note, will give us just, the same, b squared. So we are having a situation here where we've already simplified what we have in the right-hand side. And so what you're remaining with is x plus b all over 2a squared being equal to negative 4ac plus b squared all over 4a squared. Great. Awesome. So then we are going to afterwards try and just a minute. We are going to then afterwards try and find the square root of whatever we have in the left hand side and what we have on the right hand side. All right. So basically, we're going to find the square root of what we are having here and the square root of what we have here. All right. That's the next thing that we are going to do. So let me flip on to the next slide because we don't have enough space, and then we continue from there. Okay, so I've created enough room. So note, we are then supposed to try and find the square root of what we had in the left hand side. That was x plus b all over 2a squared, and that should also be equal to the square root of negative 4a squared, I believe. Yes, and that should also be equal to the square root of negative 4ac plus b squared all over 4a squared. So before we do anything, I want to rearrange whatever we have in the numerator in this particular algebraic term here. And so I want to rewrite it such that we have b minus 4ac. So basically, I'm going to rewrite this so that we are finding the square root of of b squared instead. So b squared minus 4ac. I haven't changed the value, just the same thing. All right, all over 4a squared, all over 4a squared. All right, so the square root of x plus b all over 2a will be x, will just be x plus b all over 2a there. All right, so basically the root and 2 will simplify each other out, and so we'll be left with x plus b all over 2a. And then, of course, on the right hand side, we are going to have a situation. So with the numerator, we are not able to find any absolute square root. Okay, any definite square root. So we're just going to we're basically going to have it as a plus or minus square root of b squared minus 4ac. However, I want you to look at the denominator, and I want you to notice the denominator we are having 4a squared. All right, 4a squared, we can find the square root of 4a squared. The square root of 4 is 2, and the square root of a squared is actually a. And so this is what we're going to have as our square root for the denominator. So we have a situation where we've already found the square root of the left hand side and the right hand side. But remember, our focus is to find the value of x. So we are going to write it such that x is the subject of this formula. So we are going to then have x being equal to, we're going to take b all over 2a to the right hand side, and that will change its formula, its sign, and so it will be negative b all over 2a. All right, it's going to be negative b all over 2a plus or minus the square root of b squared minus 4ac and all that all over 2a. So we are almost done, because I want you to note we've already equated the whole equation to x. All right. However, yes, we've already equated the whole equation to x. However, what we need to actually do is write the whole equation on the right hand side as an algebraic fraction. All right, notice that we are having our LCM as 2a. So we're going to have it as x being equal to our LCM, which is 2a. All right. So we're going to have a situation where we have 2a dividing by 2a giving us 1 times negative b. So it's going to be negative b. All right. Plus or minus 2a divided by 2a, just 2a, and multiplied by the discriminant here, we are basically going to have it the same way, b squared minus 4ac. And so this here is what we call the quadratic formula. All right, this here is what we call the quadratic formula. All right, that's what we call the quadratic formula, and we use it generally to solve quadratic equations. All right, we use it to solve quadratic equation. In the next class, not this, we will look at numerous example, numerous example where quadratic formula is actually used to solve quadratic equations. This was more of a fun class. Nothing to really give much attention to. If you've understood what has been done, you can try and redo it for yourself. But the most important takeaway is how the quadratic formula actually looks like, and that it is equal to x. It's x equal to negative b plus or minus the discriminant, which is the square root of b squared minus 4ac all over 2a. So that is the takeaway, and I'm wishing you all the best in the next class. Thank you, and have a blessed day.